All right, hello there, this is Garrett. Welcome to the next tutorial, which is CL05, reading raw data. Now, this tutorial is probably going to be one of the most important ones when it comes to developing on this device because, just in general, everything that you do is going to be backed by data. You have to have good data, you have to understand your data, and understand, in the case of, whether it's lab work or creating a game or training artificial intelligence, you have to truly understand, the quality of the data that you're collecting and be able to delineate, events you want from events you don't want, in the case of, we're looking at obviously a CL1 device here, there is some activity on it. Um, and, when we come here, how we are going to quantify this is in samples, frames, and timestamps. So a sample is a 16-bit signed measurement from a single electrode. So there is a single electrode on channel 29, for instance. And we have 64 electrodes. So it's important to note that there are ones in the corner that are, basically grounds. And then there's this one right here, which is also, I believe, I forget what channel 4 is. We went over it in a previous video. But we have 59 active channels, I believe. And, to convert the raw sample to the raw UV value, we multiply it by 0.195. Each frame is allocated by a numeric identifier called the timestamp. Timestamps increased by 1 for each frame. Now, you can always get the current timestamp by calling neurons.timestamp, and we kind of went through this before. The CL package has some special stuff, for keeping time, as opposed to using the native Python package alone. So that's very important. And we could see, when we run this, the first timestamp was 204.106, second was 107, and the difference was 25.001. Now, when we come down to just flat out reading raw data, we import the CL package with cl.open as neurons, frame equals neurons.read, and 1 and neurons.timestamp, and we print the frame. And what this is doing is we're doing a arbitrary number of frames, so that it's a little data frame that's happening down here that we're able to print out. And to read, a full 2,500 frames, and you can see the ellipsis here, we're getting 2,500 different frames of data, from, various time frames right here. And, we're just obviously changing this integer to 25,000. And if you basically come down and you want to look at, 5 seconds in the past, because we're iterating, here, you do minus 2,500 and, it will show you, from up to 5 seconds of the past as well, from the last 2,500 frames, which would be essentially 5 seconds. And then when you notice, you'll notice that that would complete immediately when you do run it. And it's also possible to wait for a future timestamp and read, so this one, to kind of, we're doing a plus right here instead of a minus. So it's waiting for a time in the future to record those frames. I find this super, super useful on the live device when basically you have a planned stimulation. You know that stimulation is going to happen at a point in the future, contingent on the health of the culture, contingent on maybe output of the spikes on each channel. And what you do is, you can set that recording, to, so that raw data more precisely, that raw data to be captured at a certain time stamp in the future when that stimulation is going to happen. So it's super important to kind of have that control over things, hey, if you're not trying to generate massive amounts of data and then sift through it later, that's the way to do it. When it comes to plotting something, okay, so, this is important, so we're going to look at plotting channel 2 right here, per kind of this, per this approach. And for the frame by frame approach. And, I want to be very clear here that this ends up being, a lot more granular. You have a lot more granular level control when you're going frame by frame. um, and using the timestamps to gather, so again, it runs at the fixed 2500 frames per second, so once every 40 microseconds, I believe. And you know down here again, like the last CL04 tutorial, we're using matplotlib. We're capturing 10 milliseconds. We're capturing the, frames by the captured milliseconds, so 1000, times the milliseconds. And on channel 2, so, for 10 milliseconds, 250 frames is what this creates. And we're looking on channel 2, which is right here on the device. Now we're plotting the channels using matplotlib down here, and you could see, kind of just that activity. It's kind of flatlined there. I'm going to actually go ahead and we're going to change it to channel 51, just so we have something that might show you a little something. Oops, but we'll see if we can pull the stuff off channel 51 just for the look of it. And you can see it's a little bit different, so that is pulling off of this channel 51. A little bit different, going frame by frame, but just to give you kind of an idea of how it works, when we're reading raw data frame by frame. Thank you very much, and look forward to seeing you in the next tutorial.